Lesson 11.2 is particle motion from a graph. So we have done the little bunny activity where we saw him moving right and left and speeding up and slowing down. Now we're given a graph where we have to determine what things are happening. And there's two different graphs you have to be able to analyze. The first one is your position graph, and then we'll look at when you have velocity. So it says a particle moves along the x-axis so that its position from time of 0 to 18 is given by x of t. So sometimes you might see a graph that's labeled x of t. That's a position of a particle over time. Whose graph is shown in the figure below. The inflection points of the graph are marked with green circles. This was actually a note I made for myself and I forgot to take off, but this will help you know you've got to put an or, the word or, between your intervals for your answers on Delta Math, or you can do comma and do like separate answers. But you can't just put comma. Figured out the hard way that you can't put commas between your answers and put them all in the same answer box. It doesn't take it. But so let's look at this. So part A says, find all intervals of time when the particle is moving to the right. I know that particles are moving to the right when the velocity over time is positive. And this is not velocity, this is a position. But remember that velocity is just the derivative of position. So I'm really looking for where is x of t increasing or having positive slope. Okay, so like saying here from 0 seconds to 4 seconds, I know my velocity is positive because my position graph is increasing. So I would say from 0 to 4. Then it would be moving left because now my velocity is negative. Then I would increase again from 7 to 10. So again, this is where you're going to want to hit the comma button to pull up another answer box on Delta Math, or put the word or between it in one answer box. Then it's moving to the left and then moving to the right. So 15 to 18. All right, part B says find all values of t when the particle is at rest. I know a particle is at rest when the velocity at a certain time is 0. And on a position graph, that is where the slope is 0. So it could be a min or a max or some kind of little flat spot, anywhere there's a horizontal tangent line. So it would be at rest at 4, 7, 10, and 15. So talk yourself through that. When velocity is 0, that means it's not moving, it's at rest. So those are your mins and maxes, or any kind of flat tangent line. Part C, find all intervals of time when the particle has a negative acceleration. An acceleration is really the second derivative. I'll put a of t is x double prime of t. And so that deals with concavity. So I want a negative acceleration to be when my position graph is concave down. If I wanted a positive acceleration, I would want concave up. So we're concave down from, looks like here, I'll actually do it here, on the outside here to our first inflection point at 6. So I'd have 0 to 6. I would have concave up. I would have from 8 to 12, and then we're concave up the rest of the way. So just those two intervals. And then the last thing is final intervals of time when the speed of the particle is increasing. And speed is kind of weird on a position graph, but what you need to know about speed, it's when velocity and acceleration have the same signs. So any graph, that's what you're trying to tell yourself. Velocity and acceleration need to have the same signs. What that means for our x of t graph is if I want to know velocity, I want it to have the same slope And then acceleration is concavity. So it can be increasing and concave up, or decreasing and concave down. So let's analyze this. First, I am increasing, but this piece is concave down. Then I am decreasing, and this part is concave down. So here, from a time of 4 to 6, that would be when the speed is increasing. Okay, then I go from decreasing but concave up, increasing, concave up for just 7 to 8. 1 second. And then I'm increasing but concave down, decreasing, concave down from 10 to 12. I'm decreasing, concave up, increasing, concave up from 15 to 18. All right, now let's look at a velocity graph, which I almost think is easier than a position, because these give me the certain, or the absolute values of the speeds at every second. So first it wants us to final intervals of time when the particle is moving to the left. So remember we talked about when velocity is negative, so I'll say less than 0, that's when it's moving to the left. If velocity is positive, it's moving to the right. So where is this graph? Where the velocity is negative? Literally where these points are below the x-axis. So here, and here, and all of this. So we would say between 2 and 5, between 8, and we don't even have to stop there, from 8 to 18. Okay, so literally these are the points. So when it's at 2 seconds, it has a velocity of 0. When it's at 4 seconds, it has a velocity of -2. These are the velocity values for our y's. Part B, find all values of t when the particle is rest. It kind of just said it. We know when velocity is equal to 0. So those are literally going to be the x-intercepts. So that'll be at 2, 5, or 2, 6, 8, and 12. Okay. Part C, find all intervals of time when the particle has a positive acceleration. And we know that acceleration, I meant to do a different color, is really just the derivative of velocity. So it means the slope of our velocity graph needs to be increasing, so positive slope. So first it's decreasing, and then from 4 to 7, it would be having a positive acceleration. Then it's decreasing, then it's increasing between 9 and 12. So that would be all positive acceleration, where our velocity graph is increasing. In part D, final intervals of time when the speed of the particle is decreasing. And we talked about how the velocity and acceleration, I don't know why I abbreviated it like that, but the velocity and acceleration are the same signs. Means it's speeding up. If they have different signs, means it's slowing down. So what you're looking for is saying this piece here is decreasing, but it's positive velocities because it's above the x-axis. So this first piece would be slowing down, and then this part is decreasing and it's negative velocity, so that has the same sign, that's speeding up. Then from 4 to 5, we've got where it's increasing, so it'd be a positive acceleration. and then we're negatives, those are opposite signs, would be there. What I want to tell you is, to me that makes sense, is we're slowing down when we're getting closer to a velocity of 0. So either when we're headed towards the x-axis from above it or below it. So I can look and see, okay, here we're getting closer to 0. Here we're getting faster because we're going to the left, a speed of 2, whatever. It's just the absolute value of these. And then we would be slowing down. We're getting closer to a velocity of 0, or holding still. And then we get really fast. Going to the left, we speed up to going a velocity of 5 feet per second. So to me, it makes more sense to say I'm slowing down when I'm getting closer to the x-axis, which is a velocity of 0. I'm speeding up when I'm going away from the x-axis. So we would have from 0 to 2, 4 to 5, no, 4 to 6, I cannot read that, and then 7 to 8, and 9 to 12. And that's it.